All right, all right. Welcome to the next latest and greatest webinar on CIS-210 here at GMC. I am Professor Lusby, and I wanted to create another webinar recording here where we're going to go over what exactly it is that we need to do for week 6. Okay, so I assume everyone is familiar with the classroom at this point. One of the most important links is this wonderful um, virtual desktop that we can use to complete our assignments. And I am going to be demonstrating that here in just a second to show you, give you some guidance on how to use that virtual desktop to complete your assignments. All right. So we are in week 6. Um, so I'm going to jump right down here to week 6, and let's kind of go over what it is that week 6 is about. If we click on this overview and objectives, we're going to see that we're going to study um, a looping construct, okay? And this is a very important concept where we need to be able to have the code loop back on itself and execute same of the code more than once. And this is going to come in really handy for things like data processing, for things like the command line interface where we're not sure how many options that the user wants to run, and things of that nature. So that's what we're going to be talking about this week, and I believe it is covered in, yes, chapter 6 of your book. And if we look at chapter 6 of your book, it is called Flow of Control Part 2, because remember that last week in chapter 5, we talked about the selection or the if, else, and switch statements, right? The ability to add conditions, and it executes unique branches based on if those conditions are true or false. Well, very similar in chapter 6, um, we also have conditions in these looping constructs, and if the condition is true, well, then it's going to keep looping. If the condition is false, well, then it's going to fall through the loop and continue to execute the code below it. And we'll see that there is a couple of different options we have to loop here. There's something called while loops or do while loops, also known as an event-driven loop, where we basically keep looping until that condition uh, is true. Okay. And then we also have what's called a for loop or a counting loop, where we can give it a specific number of times that we want the program to go through that loop. And that comes in handy for things like data processing of arrays where we have a finite number of elements. Okay, so for sure, read over chapter 6, get comfortable with uh, its contents. Lots of good examples are here in the book demonstrating how to use these loop constructs in pseudocode, but also using Java, right? Here's an example of a while loop. Here is the condition, and as long as this condition is true, well, then it's going to keep executing this code. The minute that this condition is false, it's going to jump out and come down here to that selection or that if statement. All right. And I think even, yeah, that's the while loop. They should give you some examples of some for loops down here. Yeah, in 610. And yeah, here we can see a for loop or a counting loop. Notice it is a little bit different than a while loop, right? Because the while loop just has this condition. With a counting loop, you add what's called an initializer, which is where uh, the iterator or the counting variable starts, in this case 1, and we add something called an incrementer at the end. So as the computer comes in and executes this for loop body, when it gets to the end and it comes back up here, it's going to use this incrementer, and I++ means I equals I plus 1. So it's going to increment I by 1. So we're going to start at 1. We're going to keep incrementing by 1 with each loop. And then as long as I is less than or equal to 5, that's our condition. That's true. It'll come down here. So as soon as I is equal to 6, this condition is false, right? Just like the while loop. Once this condition is false, it'll jump out and it'll jump over the loop body and continue down here to line 25. All right, so that's the basic idea behind these loops and the basic idea behind chapter 6. There is a link here to some supplemental uh, resources, optional resources. Feel free to take a look at those. I believe some students, again, find these very useful. Others find it confusing. Always, always, always go back to the textbook. And if you need further help after looking at this, after the textbook, then by all means, email us. That's why we are here. Okay. What else? Right. So here's the nitty gritty for week 6. We have these 4 assessments. As always, discussion forum. However, you have 2 programming assignments, not one, very similar to week 4. You're going to have a programming assignment where you're expected to be able to come up with it from scratch. Same with, all right, remember this is the CIS-210 project that was defined at the top of the classroom. We worked on part 1 in week 4. We're going to work on part 2 here in week 6, and I'll go over that here in just a second. And then finally, we have the typical week 6 quiz. But let's go in and let's take a look at each one of these guys here. And let's take a look at this discussion forum first. A lot of you have started working on it already. They want us to take a look at programming activity 2 using for loops in a textbook and try to complete it, right? The idea is that we gain some knowledge doing this exercise and we can talk about that knowledge. Even if you can't come to the solution, at least you can kind of see where such a solution might come in handy for this particular programming problem. So let's take a look at Chapter 6, Programming Activity 2 here. And we'll see that here on page 323. And they do give us a bunch of files that we need to import and start with. And I'm going to show you that in a second. But at a high level, I don't know, what do we call this? A grocery simulator, a grocery checkout simulator. All right. And the idea is that the user puts in a value up here into this text field. They click on this checkout button, and we're supposed to implement a loop that's going to go through and process that many items in the cart. And if we do so properly, we should see these items go across the conveyor belt, and we should see this subtotal update. All right. In particular, they want us to modify inside of the caching drawing.java file. There is a checkout method, and in this checkout method, it is passed this parameter called number of items. And so this is the beautiful thing about modular programming and creating these well-defined functions. These functions are just like are part of a computer program, which is part of a computer. And the architecture behind a computer or a computer program is that it all falls under the IPO paradigm: input, process, output. And for every function also meets the IPO paradigm. This is your input, all right? Any parameter passed to a function, that is your well-defined input. We're supposed to take this input here, process it somehow, and it's describing here as to how we should high-level pseudocode design, like I provide in a lot of my guidance projects. And we're supposed to take this and convert it to actual code down here. All right. All right. So how can we go about doing this? Let's launch our handy-dandy remote desktop, right? Let's go to the classroom inside of the desktop because we need to download those textbook activity files in order to be able to do this discussion board. And if you scroll down a little bit here, click on this guy here, CIS-210 Programming Assignment Frameworks. It's going to download the file. We click on this zip file and we see the source code for all of the chapters. In particular, we are interested in chapter 6, right? In particular, programming activity 2. And you're going to see there's a lot of files here. All right. The good news is, since we're going to run this in NetBeans, we don't need any of these class files. So just ignore the class files. What we do want to import, and I'm going to show you how to do this in a second in NetBeans. What we do want to import is here down to here, right? Well, how many files is this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So notice how these projects are getting a lot more real world, where lots of classes are involved, and we need to add all of this in order to have the project compile and run properly. All right, so how do we do that? So let me go ahead and minimize this. Let's minimize the classroom. Go ahead and double click here, NetBeans 8.2, right? Let's launch NetBeans. And you should be familiar with this now. This is the typical screen, right? Your project's window on the left there might look a little bit different, but in order to do the discussion, let's do what we always do: File, New Project, right? We don't ever want to reuse old projects. It confuses NetBeans. We always want to go File, New Project, Java application. Let's give it a nice descriptive name. What is this? CIS-210. This is what, week 6 assignment. Discussion. Sorry. Right? Call it week 6 discussion. Uncheck this. Uncheck this because we have code that we're going to import. Leave this as is. All right, go ahead and click on finish. And if I'm going too fast, please pause the video and try to, catch up and then either rewind or continue to follow along. All right, so now we have this nice empty project, right, for our week 6 discussion. Doesn't have anything in it. So now what we want to do is come over here, remember File Explorer that has all the files that we just downloaded. And don't forget this FXML file. All right, this is an FXML application. You do need this along with the other Java files. There should be 12 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Drag, hold the left mouse button down once you have all of them selected. Hover here over default package and release the left mouse button, and you should see it's imported all of the files. Now, do we need to know what all of these files do? Would be a super interesting topic. I would probably need at least a couple of hours because you're going to see that each one of these has a unique class with unique methods. And in fact, just to kind of show you, where is it, Navigator? Again, the whole reason we're using these nice full-fledged IDEs like NetBeans is they help us look at all of these files at a high level. And if you pop up this Navigator window, and again, this is completely optional, okay? Everything I'm talking about right now, I'm just showing you how cool this stuff is. You go to one of these classes and look, it breaks out, well, hey, here's your class called cart, here's all the methods in cart, and oh yeah, here's all the member variables that exist inside of cart. And when you get to these really large projects in the real world, let me tell you, you're going to want to use a full-fledged IDE because it's going to help you work way more efficiently. All right, so don't be afraid to spend time with the IDE and explore its different features because it will make you a much more efficient programmer. All right, and it'll do this for all of them. Right? Well, here's cashier application class, has 2 methods, right? Here's the controller class, has these methods and these. All right. So for this discussion, all we need to do is it told us to go here in the cashier drawing, remember? Where does it say it here? Yep, cashier drawing, and we need to find a method called checkout. So here's cashier drawing. Here's the method called checkout with the input. Here's the pseudocode design for the process. And notice that there's no real output. This is what's called the return type of a function. And we haven't really talked about that yet, but uh, don't worry about that. Basically, high level, we need to accomplish uh, this pseudocode design using this parameter called number of items. All right. All right, what does it tell us here? Parameter of this method, number of items. So this guy here represents the number of items in the cart. So what's going on here is when the user types in a value into this text field and hits checkout, it's going to take whatever that value is and stick it here in the number of items. That's the way the GUI is passing that number to our checkout method. All right, it's the number that the user typed in. Then using a for loop, calculate the total price of the groceries in the cart. Uh, well, that's fine, but my next question would be, well, how the heck do I get the groceries out of the cart? Aha, there is a get next method that will return the next item in the cart, which is an item object. All right. So this is critical knowledge. We definitely need to use this get next method, all right, in order to obtain that next grocery item out of the cart. And then it tells us, well, the last statement in the for loop, make sure you call the animate method. That is the other important part. If you don't call the animate method, you're not going to see, the GUI is not going to be doing anything, and you're going to be scratching your head. So, oh yeah, and then call the animate method with whatever is the actual total, the total price of all the items, of all the grocery items processed thus far. All right, so we need to call animate with the current total price. And then it also lets us know, well, that's fine, but how do we know the price of these grocery items that we're obtaining with GetNext? Well, we can call getPrice inside of that item class, inside of that grocery item in order to get its price that we can use with on total. All right. So high level, this is what it wants. All right. Let me show you one solution. All right. Here is, I did exactly what I just showed you, right? Created that week 6 discussion project, added those files exactly like I showed you, and then came in here and completed the checkout method with one possible solution. Is this the only solution? No. It's the beauty of computer science. There's 10 different ways to do the same thing and sometimes even more. But this is my interpretation of the pseudocode design, and it does seem to work. And what I want to do here is step through this, all right, and make sure we understand why this is doing what it's doing. All right, so I'm going to put a breakpoint here on line 61, and I am going to launch the debugger using this guy up here. All right, and we're going to see this program in action line by line. So I'm going to hit debug project. Yes, we want the cashier application. And it's going to launch the GUI. And again, as long as you're using NetBeans 8 and as long as you have JavaFX installed, it should be happy and you should see this GUI. All right, for the number of items in the cart, I'm going to say, let's say 3. And I'm going to click on checkout. Watch what happens. When I click checkout, that is going to call this method here, and we should see it stop on line 61. Okay, so this is going to generate an event that's going to call this method, and it'll stop here. It should, anyways, stop there on line 61. Let's hit checkout. All right, so the checkout has called, the checkout button called this checkout method. Notice that number of items is 3, right? Notice that we can see that down here in the variables window too, right? This is what's in memory. Number of items is an integer, and it's currently set to 3, and we can also see it by hovering over number of items on line 29. So when you stop in the middle of a stop on a line when you're using a debugger, you can see all this cool stuff that's in memory. You can actually it makes sense why the computer is doing what it's doing. That's why I can't stress enough. You want to get comfortable with the debugger, especially if you're going to be a programmer in industry. They will expect that you know how to use the debugger. All right. All right, so we're on line 61. It says Well, first of all, why are we creating this line here? Total equals 0. Well, because up here it told us that we're supposed to be, right, figuring out how much all three of these grocery items cost. We're supposed to come up with a total. And so that's what I've done here is declared a variable called total. We're setting it equal to 0 because right now we don't know how much these groceries are yet. All right, so we declared this total guy ahead of time. We set 0. So when I click on step over here, I would expect to see a new variable called total here in memory, and it should be 0. All right, so I'm going to click on step over, total. It is a double, which means a floating point value. It is set to 0.0. So that makes sense. 61 is good. All right, 62. This is where we're getting into some new this new for looping construct. And there's a lot going on in this line of code. All right. When you first hit this for statement, it's going to execute the initializer. And this initializer here should set I equal to 0, and we should see it here in memory once I hit step over. The next thing it's going to do is it's going to look at this condition, right? Well, if I is 0, is 0 less than number of items? Well, number of items is 3. So yeah, 0 is less than 3. That's going to be true. So that's true. We go into the for loop. If this is false, we jump out of the for loop. All right. So when I hit step here, I'm not sure if it's going to do this and then this, or if it's going to do both of these things at once and jump down here to 64. Let's find out. But either way, in my head, as you're stepping through code, try to think like a computer. Okay, what's it going to do? And if the next line of code doesn't do what you expect, why? Why didn't it do what you expect? It's a very eye-opening experience, and it's what allows you to correct the bugs. All right, you can't just look at code and know what it's going to do. You literally have to step through it line by line by line, and the debugger helps you do that. All right, so here I'm going to step over. I would expect to see it jump down here to 64, but maybe it jumps over here. Let's find out. Okay, I hit step over. All right, so it did both things at once. Notice I, right, integer is set to 0. It executed the initializer. It also looked at this condition here. Well, is 0 less than 3? That is true. So now it's gone here into the for loop body. All right. And remember, this part here is not going to happen until after we get to the end of the for loop and it comes back up to the top. All right. This only happens after the for loop has run at least one time. All right, so we understand why we're inside the for loop. Let's look at line 64. What in the heck is this? All right, and this is where things are a little bit weird because we're on chapter 6. We haven't, well, yeah, we did. We did learn about using classes in chapter 3. All right, and that's what's going on here is we're using this getNext method that it told us about up here, right? We're calling this getNext method, and this getNext method returns the next item in the grocery cart. So because this returns a value, it's going to stick whatever that grocery item is here into this this new item variable. All right, but we have to declare, just like we declare an int, just like we declare a float, we have to say, hey computer, this variable called item is an item object. All right, just like we did with the scanner. Right? So here we're creating an item object and we're calling the getNext method. The getNext method will return it and store it inside of this item object. At least it should. That's what we expect. So I'm gonna hit step over here, and I would expect number 1 to see item down here in memory, but number 2, item should be a legitimate grocery item. So I'm gonna hit step over here. We're gonna look for it down in the variables window. Bada boom, bada bing. Here's item. It did create it. Notice it is a serial item. It is a, where's that? We are in the, where is the projects? Here we go. Cereal item. Notice how many different grocery items it could be. It could be cereal, could be milk, orange juice, I guess that's it. It's the most important, right? Um, so yeah, look, here's your item. Here's the inherited. Look, here's all the member variables, but we don't care. We don't need to know about any of this. But what we do need to do is look at the variables window and go, okay, it did return back a serial object. All right. So that did what we expected. Line 64 did what we expected. Now, line 65, here we're actually going to use that item object that we just grabbed from the grocery cart. We're going to call its getPrice method, and getPrice is going to return the actual price of that item, and it told us to do that up here. Use getPrice. Use getNext, then use getPrice. So as long as you use the item object, you can call getPrice. That's going to return the price, and we're going to store it in this new variable that's a double called price. So when I step over line 65 here, I would expect to see a new memory item variable called price, and I would expect to see a legitimate price inside of it, whatever the cost of cereal is. All right, so let's step over 65. Let's see what happens here. And 65 sure is. Here's our variable called price. It is a double. That makes sense. It is 3.5, I assume dollars. $3.50. So that looks good to me. Now in line 66, okay, let's take that price. And remember, plus equals is the same thing as total equals total plus price. It's just shorthand. And a lot of old school programmers like to use this shorthand, so you do kind of have to know what it means. Even though we could rewrite this as total equals total plus price, it'd be much more readable. And so either way is fine. All right, so right now total is 0, price is 3.5. So when I hit step over on line 66, well, 0 plus 3.5 is 3.5. I would expect total to update to 3.5. All right, so let's hit step over here. And it did. Total is updated to 3.5. All right, now that we've got the new, let's call it subtotal, right? This is the first grocery item. We're going to call animate because it told us up here. Once you have that total or subtotal, call animate with that value. And this is going to tell the GUI to display something. That's what all these animate calls in the textbook do. And it's just so that we can kind of see the GUI doing something and make us go, ooh, ah, okay? So when I hit 67 here, though, it should do something on the GUI, but I guess I'm going to have to hit step over and then click on the GUI real quick in order for us to see it. But if I don't click fast enough, we might not see it. So let's try it. I'm going to hit step over and then look at the GUI. No. All right. So when you're in the middle of the debugger, that has a weird side effect. Sometimes it is when you're stepping through the code like this and there's animations, sometimes the GUI doesn't update. So what we're going to do here is we're going to step through all 3 grocery items, and then I'm going to run it instead of debugging it, and you'll see that this animate call is doing the right thing, but we just know animate does something right now. We can't really see it or tell what's going on. All right. So there are some limitations to running the debugger. If you have animations or real-time events going on in the GUI that this code causes, yeah, you're not going to see that in the middle of a debug session. All right. All right, so we jump back to the top here, right? Because we got to the end of that for loop body. And now we're not going to run this again. Remember, that's the initializer. We're going to run this. We're going to run this I++ guy, okay? Because it was at the end of the loop. We're coming back to the top. It's going to run the incrementer. And when I hit step over here, it should increment I to 1, because that's what I++ does, right? Should increment I to 1. And it's going to check this condition over here and say, well, is 1 less than 3? That should be true, right? So because it's going to do those 2 things, I should see it jump down here to line 64. I should see I equal to 1. All right, so let's see if that happens. All right, did jump down to 64. Let's take a look at I. Yep, I is 1. It ran the incrementer. That is a true condition, so we're back in the inside the for loop again. So now we hit 64 again. Well, guess what? We're going to go grab that next item out of that grocery cart, and notice that the last cereal item went poof. right? It's gone because this is a local variable inside the loop. Um, eh, it only lasts until you get to the end of whatever the body is. But the thing is, we don't care. We don't need that serial item anymore. What we're interested in is the next item in the cart and what its price is. So we're going to create another item called get next to get that grocery item, and it should store it here in this variable called item. Let's see if that happens. I'm going to hit step over here, line 64, and we see, yep, here's the new item. It is orange juice this time. Well, thank goodness. You need orange juice with cereal, right? Um, so we hit line 65, and then that says we'll go out to that orange juice item, grab its price. Remember, we always do what's on the right side of the equals first, or the computer does, anyways. What's on the right side of the equals, and then whatever that value is, it assigns it to whatever this variable is on the left. So when I hit step over here, I should see a price variable down below, and I should see a legitimate orange juice price. And we do. Here's price. It is a double. It is $3. Get out of here. So the cereal is more expensive than the orange juice. I find that hard to believe. All right. Then line 66. We're going to take whatever that price was, $3, and we're going to add it to the total. Remember, total is 3.5 because of the last item. So 3.5 plus 3, that's 6.5. When I click over, step over here on 66, we should see 6.5 in total. And we look at total. There it is, 6.5. So that did what we expected. Then we're going to call animate again, just because we're supposed to. That gives the GUI the information that it needs. And we're going to pass whatever the current subtotal is, which is 6.5. So last loop we called animate 3.5, right? Now we're calling animate 6.5. We're not really going to be able to see it do anything, unfortunately, okay? But behind the scenes, it is the GUI thread is doing its thing. And we go back to the top of the loop. So because we go back to the top of the loop, we do this iterator again. So I was 1, now I is 2. Was 2 less than 3? You betcha, that's true. So we should see it fall down here to 64 if it's doing what we expect. And it does. All right, I is 2. Grab the next item. So we call get next. We should see a valid grocery item appear here in this item variable again. Let's step over line 64. Yep, sure does. It's milk. Milk is, well, we don't know how much milk is yet. All right, so the next grocery item is milk, and that's stored in the item variable. Now we hit 65. Okay, well, talk to that milk object, grab the price, and then store it inside this new price variable. So when we step over 65, I'd expect to see price down here, along with a valid milk price. No, okay, these prices, I don't know where they're getting. These are not current prices at all. All right. I guess it depends on the size of the milk, but whatever. Um, so now we know, well, milk is $2. We're going to take that 2, we're going to add it to the current subtotal, right? So 6.5 plus 2 is 8.5. So when I hit step over here on 66, I would expect to see total become 8.5. Sure does. Total is 8.5. And then we're going to hit animate so it talks to the GUI and passes this 8.5 number. All right. Now, here we increment I again. Remember, I was 2, so we're going to increment it by 1. It's going to be 3. Is 3 less than 3? And the answer is no. Okay, 3 is not less than 3. It's equal, but 3 is not less. This is false. Because this is false, when I click step over here, I would expect to see it skip over the loop body and either go to the next line of code, or since this is kind of the end of this whole function called checkout, it might just jump to the previous class that called this. So we're either going to see it jump here, or we're going to see it jump to the parent object that's calling checkout. So let's see what happens here. Let me click step over. Yeah, so it jumps to the end of the method. And at this point, we've stepped through everything. We've looked at everything in memory. It all looks good. The only question that remains now is, well, what in the heck is this animate guy really doing? So I'm going to go ahead and stop it here because we verified our function works properly. It meets the requirements. As long as everything else is working well, then our application should work. So I'm going to hit stop on the debugger, and I'm going to go ahead and remove this and run it. Not debug it. I'm going to go ahead and run it. And let's try 3 items. Let's hit checkout. And every time that animate, every time this loop hits that animate call, you should see it do something here. All right, so there's the first one. There's our cereal, $3.50. Why cereal is the most expensive, I don't know. Then we got our OJ, $3. Notice the subtotal is updating. That is because of the animate call. All of this is because we called animate 3 times. And in fact, we can change it. We can do 7, right? Say checkout on 7, and notice that it's going to call animate 7 times because of this loop based on the number of items. And that is what we are sending it. All right. So, and I suppose another solution could be that use a while loop, right? And you keep looping until get next returns none, or you loop, with a while loop, and you just keep incrementing number of items by 1 at the end of the while loop, and you keep checking to see is I less than number of items. So there's lots of different ways that we can do this, but at the end of the day, we run it, we test it, we see we put in a certain number here, we see that it processes however many items you put in there, and yeah, you met the requirements. All right, so that is all right. That's that for the discussion. All right, all sorts of cool object-oriented design going on here. Um, but it's a little beyond the scope of this week and this class. All right, we'll get more into that in the CIS-211. All right, enough about the discussion, but I don't know. I really find the discussion, the programming activities from the book to be fun. All right, because the real world is going to have you more than just create a main method that does blah. All right, so what else do we need to do this week? Where was I? We were talking about discussion forum. Right, so work on that. Try to come up with a solution, make a post about it, and I'm happy. Let's move on to week 6, programming assignment. All right, so the week 6 programming assignment. Remember last week we created a NASA, what do we call it, rocket launch application that had the user enter in the weather criteria, right? Basically the wind speed and the daily temperature. And then we looked at those 2 things, and as long as it's under, we'd have to go back to week 5. I think it's under 30 miles an hour and warmer than 41 degrees, then the rocket is go for launch. All right, but they want us to upgrade this program here to where it is command line driven. All right, you want to show this to the user, and then the user types in which one of these 2 things it wants to do, and the user can push, right, select number 1 a bunch of times, maybe 10 times, and then select number 2 and quit the program. So what's typical for these types of command line programs is it's an event loop, right? A while loop that the program's going to keep showing this and keep processing this until the user selects number 2, and it's going to jump out of the event loop and be done. All right. Now the second thing, so number 1 is we got to add a command line interface. Number 2 is if the user does select this number 1, well, this should be familiar. We just did this last week. And if weather conditions are good, all right, and that's stated up here, then we also need to display this. And one of the, where is it? One of the requirements is here, simulate a countdown from the 10-second mark using a count controlled loop. So for sure the command line interface is an event driven loop. For sure this countdown here is a counting loop. So for loop, while loop. All right. Um, and then, yeah, this shows you, well, maybe the user selects one and puts in this data. Then the user selects one, puts in this data. Then the user selects two, and it exits. And yeah, I do, when you complete this assignment, uh, want you to test it, uh, not just using one condition, right? Uh, and try to get as close to 100% test coverage, code coverage as possible. Meaning, good, 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 bad, bad, good. Test the menu selection 1, test the menu selection 2, and I want to see all of this output, right? I need you to screenshot exactly what your output looks like. Please don't get creative. Try to stay as close to this as possible. It makes my life uh, a lot easier. And imagine industry. They're going to come at you with some very specific requirements as far as what the interface needs to look like, as far as what the interface needs to do. And they may not give you money because you try to get too creative and went outside of those requirements. So yes, I need your program to look and function exactly as you see here. And the user's typing in obviously the data here after these colons, but your program's responsible for everything else. All right, so how do we go about doing this? Upgrading our rocket launch program to be a command line driven program. Well, first we're going to go to our handy dandy NetBeans, right, inside of our, what do we call this, virtual desktop, right, NetBeans 8. We're going to create a new project, just like we always do, Java application. Let's call it a nice descriptive name. So that's what we like to do. This is the assignment, right? Week 6 assignment. Okay. Yeah, I would say go ahead and have it create the main class because we need to come up with this. We don't get any files from the textbook for this, right? So create the main class, uncheck this, leave this as is. Go ahead and click on finish, and we should see a brand new project here for our week 6 assignment. It's created a class for you. And of course, maybe replace the comments, the standard comments, with some better comments. And so this is what I did. That's how you set up your project for week 6. Then, before this webinar, I came up with some guidance for week 6. And I don't know, I stuck with the theme and said, all right, let me rename that class to Rocket Launch. It doesn't really specify in week 6 what the name of this class is supposed to be, so it's up to you if you want to do that. But for sure, right, you got a nice header at the top explaining what assignment this is, and then we've got our main method. All right, so where do we go from here in order to create a program that meets, not this one, that meets these requirements? Well, first and foremost, let's create some variables that can hold a lot of that data that we need, right? For sure we need wind speed, for sure we need temperature data. For sure that we're going to ask the user, well, what menu selection would you like, right? So we should probably have a variable for menu selection. And then because we're asking the user for all this data, of course, we need a scanner. Maybe go ahead and create that scanner up here and figure out the proper data types for all of these, right? Wind speed, temperature. I'm giving you guidance here. I want to see, you should be able to figure out which data type to use with these descriptions. All right, so now let's talk about the input part of this program, right? Well, first we need to show that menu to the user, right? To ask them what it is that they want to do, right? So again, don't get creative. Please make your command line interface look like this with these 4 lines and these 2 menu options. Once you display, this is called a prompt or the menu, then use the scanner to let the user type in, well, which one of these menu entries do you want? And I say store it in a menu select variable, but I guess you can call it whatever you want. But the point is you have a variable that has that user input in there. And then, so we've declared our variables. We've shown them the menu. We've asked them, well, what do you want to do? Remember that it should keep doing this until the user selects number 2. So back to what I was saying a while ago, we need an event-driven loop here, right? That's going to basically loop until menu select is the value 2. And the reason why, so if menu select is 1, we want to keep looping. If menu select is 2, then we don't want to loop. We want to jump out of here. So I would say while menu select is not equal to 2, right? Keep doing blah. What is blah? All right, well, once we're inside the loop, we know that the user doesn't want to quit. And eventually, maybe this menu has more than 2 options, but the first thing we want to do is look at that menu select variable and see is it equal to 1, right? Because that specific value that the user typed in tells the program, what is it you want me to do? And number 1 means enter current weather criteria. So when we see this, okay, user selected 1 from the menu, all right, inside of this if statement, if this is true, then we want to do all the logic that's going to allow us to enter current weather criteria. Well, what does that mean? Right? If the line above is true, then for sure we want to do weather criteria. We want to ask the user, right, for the wind speed. We want to ask the user for the temperature, just like we did last week, right, inside of this if statement. Notice how all of this is indented. That's what that means. When you see that indentation, that means all of this code here, right, all of this code here is inside of this if statement. That's why we indent, right? All this code here is indented. That means this code here is inside of this if statement. Indentation is super duper important. It defines scope. All right. To make things a little more clear, I did say end of loop, and I also said end of if statement. All right, just to try to clarify where the loop body and the selection bodies begin and end. But back up here. So we asked the user to enter the wind speed. We asked the user to enter the temperature. This is where, okay, let's check to see if the wind speed is above 30 or temperature is below 41. If that's true, right? If that is true, well, then we're going to tell NASA to abort, right? If that is true, let's go back here to the requirements. We're going to just tell them to abort. All right, if this is false and the wind speed is good and the temperature is good, then inside of this if statement, right? If this is false, that means we're go for launch. Here, we're going to create a counting loop that should start at 10 and decrease by 1, right? Create a counting loop with an iterator that starts at 10, decreases by 1. And then display whatever you're counting. Let's say your iterator is called launch count inside your for loop. Well, then display that launch count to the user. And if you do that, you should see something like this, right? 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. All right. And then basically say your go for launch, whatever, once that loop, completes. Something like that. Okay. Yeah, try to be as close to as you can. Okay. All right. So once we check to see if the user selected 1, and we do these things if the user did select 1, well then we're done with this if statement. Notice that we do need to display the menu again because we're inside of this event-driven loop. The first time we showed the menu was up here. We need to show it again before we loop back up here to the top of the event-driven loop. So don't forget to display the menu again. And in fact, if you want to make it really modular, you could move this menu item to its own function and call that function twice, but that's completely optional. You could use a do while loop instead of a while loop in order to just move this to the top of the loop. But anyways, again, 10 different ways to write the same program. This is probably what I would consider one of the most straightforward ways. Display the menu again at the end of that menu loop, and then use the scanner, right? You have to grab the user's choice again at the bottom of that loop, and then it's going to go back to the top and see, okay, well, is menu select equal to 2 and they want to exit, or is it equal to 1 and I'm going to do blah again? All right, so this is your event, and I even try to make that clear here, right? Here's end of menu select event loop. So the event loop is all of this. The menu select equal to 1 or weather logic is all of this. We are displaying the menu again using this code here. And then once this event-driven loop is done, the user selected 2, well, then let the user know that, hey, program, you've selected exit, right? Quit program selected, and you say exiting. All right. So this is one potential solution with guidance. Feel free to base your code on this. Whew, okay. So that is the week 6 programming assignment. Let's keep going, shall we? What else do we need to do? I feel a little long-winded today. Let's talk about CIS-210, project part 2. Right. Here we are, CIS-210, project part 2. So here we're going to meet the 3rd and 4th requirement, the 3rd and 4th overall requirements for your entire course project. And the 3rd and 4th requirement, but we only need to worry about this, these 2 parts of the course project right now. Request the user to input a binary number, test this binary number, this input string for compliance, and make sure that only 0s and 1s are basically present. So for example, these are valid binary numbers, right? Nothing but 1s and 0s. Okay, don't worry about converting this to decimal. Some students take this and convert that to decimal. That is beyond the scope of what they're asking you to do here. If you want to do that and you think it's fun, fine. But you don't have to. Just you're looking, are all these characters 1s and 0s? If the answer is yes, then you're going to say number is a valid binary number, right? You're going to output number is a valid binary number. If it's an invalid, the user puts in something like this, well, this is definitely not 1s or 0s, so that's invalid. This has a 2 in it, that's invalid. This has F's in it, that's invalid. This has a space in it, that's invalid. So when you run your program and you test your program, yeah, I would test it with all of these in order to make sure that, and there may even be more test cases that we're not really thinking about, but at least at a minimum, run these 7 cases. All right, how do we go about completing this? We go to our handy dandy remote desktop. We launch NetBeans 8. We say File, New Project, Java, Java Application. Nice descriptive name. We are in week 6, course projects. Make sure that's unchecked. Yeah, we do want to create a main file, and I say get rid of all these dots and all the package names in front of the actual class name. So leave that checked. Create a simple class name without projects. Leave this as default. Click on Finish. And you should see something like this. It creates another template main class for you, right? I always like to delete these comments, come up with better ones. In industry, it is using JavaDoc, by the way. Uh, you see where I say at author, at params. There is a utility called JavaDoc that will scrape your code and look for these comments and break these comments out into their own documentation file. So it's not that these are terrible comments. It's just that I'm trying to simplify things here because for a lot of you, you're brand new to programming, and I'm really just trying to keep things as simple as possible here. All right. So once you have this, right, create your project, create your main class. Um, Before the webinar, I came up with some guidance here. Course project guidance, week 6 course project. All right, and of course updated the header here. All right. Again, following the IPO paradigm, input, process, output, right? Well, first we want to create some constants and variables. Obviously, we're going to have some input from the user. I say, create, and here I am a little more specific. I probably shouldn't be about the data type. I suppose you could try to use a numeric data type, but may the force be with you if you do. I would highly recommend the string data type to store whatever the binary number is that the user types in. Another variable, and here's the thing, when you're coding in the real world, you may not realize you need to create all these variables until you're down here cranking out the actual process code. The minute you hit a line down here where you're like, oh, crap, I forgot to create that variable. Don't be afraid to come up here and add a new variable or change its name. You're like, oh, well, that's really a bad variable name. All right. This is kind of a touch and go process. But at a high level, I think these are the variables that you're going to need. You're going to need probably another string or character variable called current value, because notice that we want to, where did it go? Right, the user is going to type in a full string, and we want to go through each one of these one at a time. And so that's why I say create another variable called current value that's basically going to hit, right, each one of those characters that the user's typed in. And then another variable called isBinary. And again, there's 10 different ways to do this, but I think this makes sense, at least from a straightforward standpoint. And as long as isBinary is true for all of the letters, well then we know that number that they typed in is binary. And we're going to tell them that it is binary. The moment we hit a character that is not binary, right, like the number 2, like the F's, like a space, is binary equals false. And we're going to let the user know is not a binary. Okay. Anyways, all right. Here's input. All right. So let's talk about the rest of this. For sure, you need a scanner, right? Because we're going to be asking the user to type in input. You got to figure out what kind of scanner and what next statements you're going to use. And then request the user to input a binary number, and I say store it in this variable called binary input. All right, then what? Well, then I suggest grabbing the first character of whatever is inside that binary input string. And remember that the string class has a lot of good methods that enable us to grab different characters, to see the length of the string, to grab a specific character in the string. All right. Don't forget to look at those methods called out in your book concerning the string class, and one of them will allow you to get to that first character. And I say store that first character in this variable up here that we created called current value. All right, because that's what we want to do. We want to look at each one of these things one at a time. All right, so now that we have current value, we can create an event loop that's basically going to look at this current value, and as long as it has a letter in it, we're going to evaluate it, right? But if we try to grab the next character and it's empty, well, then we know that there's no more data to process, and we're going to fall through that. we're going to fall through that loop. All right, so we want to keep looping here until there's no more characters left inside a binary input. All right, so if this is true, right, if this is true, that current value is not empty and it has a value in it, then we're going to go inside of the while loop and we're going to say, well, is current value not a 1 or a 0? Check to see if current value is not a 1 or 0, meaning it could be anything else other than a 1 or 0. If this is true, right, if this statement is true, then let's set is binary to false. And you can even, there is a exit loop keyword, I think it's break. You can use a break to automatically break out of this loop early, because the thing is, if one character is not binary, the whole thing is not binary. But it's up to you whether or not you want to exit the loop early, because even if you continue to loop over all the characters and you don't exit early, once one of these letters sets is binary to false, that's it. Is binary is going to be false, and it doesn't matter how many other letters are binary, right? So you just have to set is binary to false one time, because it's set to true up here, but if it's set to false here, then for sure it's set to false. There's nobody else going to be setting it to true. And that's key, because once you loop over all the characters and all the characters have a chance to set is binary to false, when this loop is done, what we can do is just check that is binary Boolean variable. And if it's false, well, then guess what? If is binary is false, then tell the user, hey, this is not a binary number. You don't have to say why. You don't have to point out which character. Just tell them that is not a binary number, because one of those characters is not a 1 or a 0. If is binary is true, well, then you know, hey, all characters are a 1 and 0, and for sure, that number is a binary number, and that's what you want to tell the user. All right. So again, this is one possible solution. It may not be the only solution, but I'm trying to provide some guidance on a straightforward design for this. If you know of a better way, by all means, as long as you meet the requirements and as long as the user types in these values and you say these are valid, these are invalid, yay, because it doesn't even tell us really what the output should look like. Okay, so that's that for the week 6 course project. Feel free to use this guidance to help you on your solution. All right, what else are we supposed to be doing for week 6? Oh yes, this glorious, wonderful quiz. Well, the good news is it's very typical like your other quizzes. There's only 10 questions. There may be a few open response in there. 25 minutes, one attempt. So for sure, make sure you are very comfortable, familiar with the material before you take that quiz. All right, my gosh. Yeah, so I went a little bit longer than I wanted to today, but I really wanted to make sure that I talked about in-depth, at least give you some guidance on the course project, give you some guidance on the week 6 assignment. And again, please continue to leave me feedback. Like the video, leave a comment, send me an email, whatever it is. That's what helps make me, create these webinars and make them better. So have a great rest of your week, and definitely reach out if you need anything at all. Thanks.